All right. Hello, everybody. Today we're going to be looking at an introduction to generative AI. So, what is it? I'm sure you've all heard of things like Midjourney, DALL-E, Gemini, ChatGPT, all of these things. They can all make very good images, and they get better and better all the time. You'll know that Grok is now using Flux, which is a generative model you can download onto your PC and run on a gaming graphics card. An NVIDIA card would be a great choice, but it's all a question of how much money you've got. So, today we're going to be looking at AI that creates content. That comes in the form of images, text, and music. So for the images, that's what we're going to be looking at today. For text, you might be thinking Gemini, ChatGPT, Claude from Anthropic. For music, you could be generating full songs now with things like Suno and Udio, which are just web services. You can go on there and use them for free, actually. You don't have to pay, but you can if you want to use them more. This would be an example from DALL-E. So you can see there, that's an image prompt. Now, the interesting thing about it is it says a pair of sneakers. And the reason I point that out is because a lot of product shots, which are pairs of sneakers, they would actually be like one's blocking the other. So if you said, I want a side profile of a shoe, there aren't many pictures that are described as a side profile of a shoe, but a pair of sneakers would often look like this. So you have to think in terms of how would I describe an image, not in terms of what is it that I want. So an image caption is more of an image description, and the attention is placed with the grammar. So everything that we want in the image is in the prompt, okay? So that's something important to think, because obviously if I say, I want a cat with a red hat dancing, it's always something crazy whenever you see examples, but that's not very useful if you want to learn how to actually use this. Now we're going to get through some of this stuff real quick, because it's a bit dry, all right? But something which happened in early AI was called a GAN, and that would be a generative adversarial model. So what it's doing is it's doing two things at once. We've got a discriminator, which is looking at every image, and then we've got a generator, which is making fakes, okay? So we might say, here's a picture of a dog, and here's a generated picture of a dog. Can you tell which one is fake and which one is real? Now, over time, the pictures that are generated are going to get better, and then the discriminator is going to get better at picking the fakes. And those two work against each other to improve the model. So you start off with a bunch of blurred pixels, and you end up with something that looks a bit like a cat. And then as the GPU power is increased, we're able to make more and more complex images until they actually look photorealistic, not just like a little drawing, which you could do in Microsoft Paint, okay? Well, that's a good one. Right. So here what we're doing is we're using computer vision to determine, is this a number or a squiggle, all right? Now you might say, oh, well, it's obvious to us that's a 0 and a 1, but the AI had to learn that, and obviously it can now learn much, much more complex things than just determining whether it's a letter or a shape, okay? But interestingly, for anybody out here who's got a bit of math experience, we've got the formulas there that's going to help you to understand what's actually going on in terms of the sorting, okay? Okay. Now, I wanted to get through the GAN stuff quickly because it's kind of old hat now. A lot of the adversarial models aren't generally used as much as diffusion models, which is what everybody is actually using now. The last 2 years have seen more to do with the diffusion models, but it's important that these are still in use, but they're more used in things like science. So for the protein folding and things like that, they're actually going to be using adversarial, not diffusion based, all right? Quite simple. The generator, as I said, is trying to make realistic fakes, and then the discriminator is trying to prove that they are fake or not. Okay. And that's just basically what I just said. Now, this is the bit which gets interesting, and is probably the part that I think this is the more interesting part. So you start with an image of a cat, right? And what we're going to do is we're going to add noise to the image of the cat. Now, we're doing it with an algorithm which can be reversed, okay? So by teaching it the pattern which we made it into noise, we can reverse that and then get the cat back, okay? So if I type a black cat, it's going to denoise, but with the word black. And so then you get a black cat, not a white cat. Very simple stuff, all right? So we've taught it what the cat is and then how to noise and denoise, okay? Now, this is basically what I just said. So the forward process adds noise to real images until they become pure noise. It's using a Perlin fractal noise. There's a whole bunch of different noise patterns, but you might be interested in that. Okay, all right. So here what we've got is we've got the learning process going one way, and then we have the inference process going the other way. So when we're adding noise to our sample, combined with a text pair, that's how we're going to actually get our learning process, right? So then it understands what it is that we use the words for, okay? And then when we use those words again to predict, it can then make what it was that we've trained. Now, a lot of people talk about overtraining, which is where you spend too long training your AI model. It's sort of like a strategy to get better quality images, but it also means that your model can only make what you trained it on. So that's not necessarily what you actually want it to do, because it is able to make just about anything you could possibly imagine. But if you try to overtrain it on something, now it can only make that. My best example of this is if I was to take pictures of myself at my computer in a room and only train those photos, that model can only make pictures of me or someone else in my room. It's suddenly incapable of doing an outside image or a robot or something like that, because I've overtrained it. So it's actually like not a good way to use the system. It takes a lot of training to get a good image out of a system. So all diffusion data sets are images with text pairs, so a text file and an image. The text file will describe what the image is. Now, as you can see here, the image in the training set was a photo of this lady, Anne Graham Lotz. And you can see the generated image, it resembles her, and you could say it's recognizable, but it's actually a very low quality image. It hasn't really learned, like the sharpness isn't there. It's messed up the skin tone. It seems to be getting confused between the necklace and the shirt. There's a lot of details here which aren't good. Also, there's a lot of artifacts in the blurred background. But this was actually used as a legal case for why they'd stolen images, all right? They said, you've stolen my likeness. Now, I'd say it is recognizable, but the funny thing is, with the prompt, they should have used living in the light with, because if you trained it on that full caption, you're going to get a more accurate prediction by using the full caption. So by just using her name, they kind of broke the generation. So it's an incomplete prompt because they didn't really understand how it was trained to begin with. They've put more attention weight by omitting living in the light with. The name A.M. Graham Lotz gets a higher weight. And so that means they've actually boosted in an attempt to make it seem like it's a copy. The thing is that diffusion is a variation engine. So it can make billions of different variations on a thing. And it's not a photocopier. You have to turn it off to get it to photocopy, because any strength over 0 will change the image. It won't reproduce what you put into it. Tokenizers are also interesting because it doesn't actually see Anne Graham Lotz as 3 words. That would probably be broken up, and you'd have to check because different diffusion models use different algorithms. But I would expect Graham would be broken in 2, and possibly LO and then TZ will be broken in 2 as well. So it's actually not doing words, it's doing like bits of words, okay? All right. So, if you have high quality data sets, that can increase the scope of ability. Just like I said before, if I was having my model of me in my room and it can only make that, if I went and take pictures of myself in 7 different locations at 7 times a day wearing 7 different outfits, that model is going to be able to make almost anything because it can substitute me for anyone and all those different places for anywhere. As long as it knows what they are, it can do it. So I could be in Italy on holiday, I could be in America at Vegas, and it will look photorealistic, no problem, okay? As I was saying about, that's elasticity, okay? Because it had a wide scope and it wasn't overtrained, it's able to do transformation. You might have seen on the internet people sharing pictures of video game characters that have been made photorealistic. That's how they do that. They give the video game picture, and then with a photorealistic model that hasn't been overtrained, it should be able to then enhance that old cartoon or pixel character into something more photorealistic. Now, what I'm showing you here on the screen is an example of what happens when you overtrain it. So this model was overtrained on the Mona Lisa. So they were trying to make a perfect copy of the Mona Lisa by overtraining the model. And what's actually happened is it's just hallucinating. So you've asked for the Mona Lisa, it's been overtrained. It only knows how to make the Mona Lisa now. It can't make anything else. If you tried to tell it to do anything, it's just going to spit out stuff like this. So the pursuit of perfection comes at the cost of elasticity because they're transformers. It's not a photocopier. I would say, though, right now, there's a big grey area on the copyright. And what people don't realize is that if you get hired to work for a big company, they're going to make you use AI tools. And right now, there's no protection for that work. So I wouldn't be surprised to see a change. But currently, there's no residual or royalties or any kind of protection for the work that you've done for a company that's using AI tools. And when I say Adobe Photoshop, Premiere, there are many, many major sort of industry level softwares, and they have AI inside of them, and the companies do expect you to work with AI. So this is why I think that protection will come. It's just a question of time. So with AI tools, we must not lose sight of creative responsibility. So this one is from DALL-E, again. The prompt's way down there. I'm going to read it out. So it says, you've got to think of this like a shopping list of qualities that you'll find inside the image. So the small canvas oil painting, yep, right? It's on a chopping board. It's an orange on a chopping board. There's light passing through some segments. There's casting an orange light. So if you are into creative writing, you're going to find this very easy. If you're not so great at that, you might find it hard because it's about being able to illustrate a scene with words. So the more literate you are, the more that you'll get out of this sort of stuff. If you don't know the words, you can't evoke them, okay? So you'll notice that everything in this is in the image, all right? What people don't know, though, is that you can put multiple images in with your prompt. So in this example, we've got 4 images which are being pushed into Imagen 2 from Google. And then we've got a embedding of Studio Project Shot of. Now, when we say insert object, that's because there's a list. There's a list of different things which it's iterating through. So what it's done, it's combined the artwork and it's created 4 product shots, right? So that's literally what it's done. And that's what we call image embedding, all right? Now we get to move on to some more fun stuff. This is some of the stuff that makes the open source much more powerful than what you would normally get on stuff like DALL-E. Even though they have started adding things like this, Canny is a lot like a sketch. It's black lines on white. So we've taken a photo of a robin, we've turned it into canny lines, and then we've put that into the AI and asked for a robin on a branch. And then the images that you see, they've been constructed using that guidance, okay? Now, what that means is that you can make crazy sketches on a tablet, and then you can run it through, and it will make photorealistic whatever it was that you drew. The real benefit comes when you've got your own artwork, which is trained on your own private model, because then it's your work as well. It's not just images from the internet, but it's actually your own work. It takes a lot more effort to do it that way, but I think that is the true benefit for artists, is to do it that way. So Canny, as I said, is black on white. So this one here would be the depth model. Now, the biggest problem with when you're doing an image is obviously things are in front of things and things are behind things. And when you're just looking at a 2D, there's not really any way to convey to the model, oh, this is in front of that. So this is how we do this. It's a depth estimation. Now, depth estimation isn't new. A lot of smartphones actually have a depth sensor, and all your photos probably have a depth map built into them. So that's how it would do automatic focusing and things like that. It's all built into your smartphone. So the depth model gives us the ability to estimate, so the podium is in front of the person, and then there's some kind of deep background behind them, okay? So, again, there's your depth model. And then we can move on to the pose model. There is a whole load. I've only been able to show you some of the more important control net maps for this. But if I take a picture of myself, I can convert that into an open pose skeleton, which I can then put into the generation pipeline along with my prompt for a chef. And then this is going to create that image. And so that way I can control exactly what the pose is. Okay? So that's what the pose model is for. There are other, which I don't look in, I haven't even got any examples for, is like tile. So if you wanted to make a very, very big image, it might break it up into tiles and then tile them out so that you can make yourself like 8 to 16K images rather than just your little 1,000 pixel images that you get. Okay, HED, this one is a lot like Sketch, but it's in the opposite. So you tend to see people using this more with graphic tablets because it's easier to draw like this with a very light sketch. And then obviously combined with a prompt, you're going to end up with these sorts of images, all right? And like I said, it's more with a cartoon, and like as you can see, it's like an oil painting, this one. This works better because it's less detailed. The other Canny type was much more detailed, okay? And then if you are a CGI person or you're familiar with 3D, you might notice that that's a normal map. So you can take the normal map that's displayed in Blender, for example, take a screenshot of that, then put it into the image generation along with a prompt, and then obviously you're going to get yourself your little toy here. All right. So you can obviously use all of these at once, but it does take a little bit more fettling with the parameters to make sure that they're not all stepping on each other's feet. But essentially, this is multiple ways of having more control over composition in the image. Okay, so here's some of my stuff. So the first one is going to be a sort of non-Euclidean, vibrant artwork style. The one in the middle is going to be an abstract sort of watercolor type style. Sort of surreal as well, to be honest. And then the one at the bottom is like futuristic stuff, okay? Now, a lot of these images have been run through Midjourney, which you can go ahead and use. I think you get some free generations. And then the prompts are on the left. They're a bit too small. They're a bit too small to read, to be honest. But we were evaluating version 6 when putting our own work into it to see what it would do with it. And then training models based on the outputs, just to try and see what it was possible to do. So the ability to train your own models opens up speed advantages, obviously, because if you can do quick estimation of styles and explore them without having to actually draw them all out, you might find that that's more valuable because you can accelerate your learning. Research in art history and aesthetics is also possible with this because, as I say, it's possible to do like a speed run on blending famous influences from history to find something that you like that you maybe want to explore practically, okay? So as more and more big studios are going to be using AI tools, traditional artists are going to find themselves more and more at a disadvantage with practical arts, which has already been the case when you look at things like CGI anyway. It's not really new, it's just the next chapter, okay? And so in order to remain competitive and in order to still put your sort of artistic vision out there, you're going to have to be familiar with all the tools. I don't know if you've heard of Decroix. He's a man that he painted the first selfie in about, I think, 1790. Okay, so he like famously painted himself, which no one really ever did. He painted it in a funny way. He'd paint these funny things. And what I've done is I've trained this model on him or his, I think it was only 4 images. There's only 4 images in the public domain from Mr. Decroix. And like I said, what we've got here, epoch 16, 576 steps. So that's what those numbers signify. And the reason I've pulled out that column is because I felt that that was an early convergence point. Before and after that point, there are a lot of strange errors taking place. And if we keep going, I think I actually went on to about epoch 46, 48, I think it's 48 was the final model. And the reason I'm doing this is to teach people about overtraining and undertraining, because with the resulting models, we were able to use the farther trained model to create much more accurate representations of this art style. But with the early model, we were able to do more transformation work, so taking other images, pictures of people, and making them into this style. So it was what we were trying to do is we're trying to prove that by overtraining, you actually cut yourself off from a lot of the abilities that these AIs actually can do with your work. So, yeah, okay. All right. So, you may have heard of low-rank adaptation models. You may have not. This is the output from an enhancement model which I created. So by taking 30 different examples of architecture, we've got a structural enhancement model. So the one on the right is an AI-generated Sphinx, okay? The one on the left is the exact same image, but with my enhancer applied. What it's done is it's made it look brand new. And the reason is because I was teaching about perfect lines. I wanted all perfect lines in perspective, all edging, lots of detail. And so as you can see, I hope you can appreciate that, the one on the left looks like it was built yesterday. The one on the right looks more weathered. And the interesting thing is when you load this model in, you actually don't prompt it. You just do whatever you want as normal, but because it's loaded, it has the additional data to enhance the structural details, which is something which nobody really expected to work when they were first creating these things. All right. So you might think you can spot an AI fake, and this is about a year old now, just for the record. Image in the top left is the original. What we've done is we've used face recognition to identify the face, mask it, invert it, and then we've used Canny on the rest of the image and repainted it. So you'll note the face is the same. It might not be the best face because this hasn't been like upscaled and everything else that you can do with these images, but it shows what you can do. So, because you might think, oh, I can tell that's AI. I can tell it's AI by looking at the eyes or something. But the reality is that there are so many options available. I could choose to only change everything but the human face from a photo. And so then you're going to be like quite looking at it going, I mean, it's a bit, I would say you can tell because the Coca-Cola logos are everywhere in the background. But again, if you were just to roll like 10 versions of this, because it takes about 4 seconds to make the image. So you spend a minute making a whole bunch of them and then just pick the best one. So, but yeah, I just wanted to sort of point out outpainting, AI masking, and then by inverting that mask, we can leave things alone. So people talk about deep faking. A lot of people think that you're just going to change the face. You could just change everything but the face. Okay. So Flux, Dev, and Schnell arrived this summer. They're from Blackmagic Labs, and they're the best models out there right now. They can do text, and as you can see, we've got ourselves, and that's Decra, if you remember the Decra model that we looked at earlier, but he's been transformed into a Roman Greek statue. And that's my point with the whole, if you overtrain things, you can't do that. But because it was a loose model, it's able to fit and do the Decra without actually being that style of painting, because obviously that's like a 17th century oil painting, and now it's a photo of marble, right? The bottom left, we have, like, I wanted to see how far I could get with detail depth. So the issue with a lot of these models is they're quite simple. There's not really much going on. And so we were pushing the depth of detail to see how small we could get things. And obviously that one on the top there, it's the text. We got the name Johnson in the glass bottle or on the glass bottle. And so that's a new thing. A lot of people think I can spot AI because it can't spell. Well, that's not true anymore. It's been a couple months now. It can spell just fine. You can write whatever you want. Okay. So this is one of my models. It's a crazy design model. And what we're looking at here is design and prototyping. So obviously this could be the design of some crazy gamepad controller, right? The way that we've done this is we've given it a photo of a gamepad controller, and then we've added in this artistic model that we've trained specifically for this purpose. And then it's going to give us something which might be something that we create. You see what I mean? Because often in the concept stage, it's just this. Nothing's been made yet, all right? And it's easy to create thousands of these or whatever it is that you want to design, and then overnight you pick the best one. So it might not be this one, might be another one. But again, that's the whole point, is that while you're sleeping, it can be working for you. And then when you wake up tomorrow, you've got 1,000 designs to go through. If you're someone that's been contracted to do concept design, well, now you're getting paid while you sleep. And if it was trained on your work, you're not cheating because it is your work. So it's all a question of application, you know. And again, these designs would then be passed off for viability anyway. So it's not like, anyway, I think so obviously in entertainment and gaming, we're already seeing DLSS from NVIDIA, which is upscaling frame data for, you know, video games, right? So you get higher frame rates or you get higher resolution. If any of you play games, you'll probably already be messing around with the settings for frame generation and upscaling. And then for better or worse, ChatGPT. So you can have some really cool experiences with ChatGPT online, but you can also watch some really bad TV shows that were clearly written with ChatGPT. Everyone says this is the worst it'll be. And you've got to remember that a lot of the TV shows that come out now were actually written 2 years ago. So whatever version of AI they were using to assist the writing was nowhere near as good as it is now. You can use things like Notebook LM from Google, just came out this week, and it's possible to chuck a whole bunch of sources in and just have it write reports, articles. It'll even do a podcast now where two fake people talk to each other about it. It can be interesting because what you can do is you can do like promotional stuff. So say you've written a book or you've got a podcast, you can have it review it and then put that on social media, which is kind of crazy because you certainly couldn't hire people to do that before. People say this is the worst it will be, the worst it will ever be. I like to say this is the cheapest it will ever be, because if you give it another year or two, the prices are going to go up. Okay, the graphics cards are going to be more money. But right now, you can get away with a 12 gigabyte GPU, which is about £300. So you can do almost everything on a 12 gigabyte GPU. Yeah, it would be nice to have the biggest and greatest, but unless you're earning money with it, probably not the best choice. Although if you are making money with it, you'll pay it off in no time. So that's not real. That's one of my models that was trained on electron microscopy, okay? So it's just estimating what it thinks electron microscopy looks like, okay? But I wanted to use that as an example because right now, they're already using generative adversarial networks in modeling the migration patterns of various animals. So I think in Africa, they actually have like a reservation patrols, and the patrols, the routes they take are actually based on the AI prediction of where they think the animals are going to be. And that's reduced the amount of patrol that they actually do. And I think in one area, they were able to predict even where human hunters were going to be that were illegally poaching. So they used the AI to predict the migration of the animals, and then were able to predict where the poachers were, and then they were able to catch them before they even got done anything. And so that was all done by looking at the patterns on the map and using the AI to predict where people were going to be and at what time. So that's already a thing. Protein folding. So there's been a lot of big projects on protein folding, and that's one of the big areas where AI is currently being used to try and do that. And then with drug discovery, I'm sure we all heard about the amount of money that went into drug discovery during COVID when they were trying to use AI to find a cure, okay? And then again, virus identification. Recently in the news, they identified, I think, over 100,000 new virus species in the thermal vents at the bottom of the ocean, and that was all done with AI. So, like I say, everyone talks about deep fakes, right? Who are these guys? Do we know these guys? So, obviously we've swapped their faces, but basically, the challenges and limitations of bias, that's what I wanted to talk about here. So, if you don't know the data that you're training, how can you have a good output from your model? So, a lot of the early foundational models, they were all trained with scraping billions and billions of images, for example, right? And then those images would have come with random file names, or they may have even used early AI to tag them, okay? So it's low quality data that no one really knows what any of it is, okay? And they just kind of threw it all at the wall to see what sticks, and that did work. But what we're starting to see now is properly curated models. So just to give you an example, ChatGPT 4.0 was trained on about 1 trillion parameters now, they say. And there's a model that's come out of Australia from the Allen Institute, and theirs has 72 billion parameters, and it operates at the same efficiency. And the reason is because the data was all curated. They have good data intimacy. They know what it all was. They're not just shoving stuff in because they can. They actually have high quality data there, right? So the mass scraping of data, it actually damaged the outputs of the early AI models. And now they're starting to cull that poor quality information, right? Like, for example, you could have pictures of Batman tagged Spider-Man. That's obviously going to affect what the definition of Batman is, okay? And then low participation rate. There are many countries in the world that aren't digitally connected. They're not making photos of themselves and posting themselves on social media. And as a result, there's less data from those countries, which means that the model isn't very good at predicting that, okay? All right, here we are again. So, there are ways to prove that an image is real. So is it really so much of a concern that people can fake? I mean, people have been making Photoshops for 20 to 40 years now. So is it really so much of a big concern when we know we can prove if something is real or not? I mean, the best way is to ask the person in the photo, was that you? And they say no. So, I don't know. So the human operator is in charge, all right? None of these systems can work on their own. So that means the human is orchestrated the generation. So you might have programmed it to do a script that then does the prompts. It's still a person in control. Somebody ultimately has to start up the machine and get it to do something. And so, you know, people talk about legality and all this sort of thing, but in the field of hacking, if you were to write a worm, which then went out on the internet and automatically did destructive things, you would still be, you know, responsible. And so the same will be true for AI. It's just a question of time for the litigation to actually become enshrined in law. All right. So, copyright and ownership. The grey area over awarding AI copyright has been a dismal affair. Enemies of AI mistake it for a villain from science fiction. A lot of people have this doom and gloom thing like Terminator. You know, it's going to be Terminator, or it's going to be RoboCop with his hidden directive, right? It's going to be something like that. But it's going to be a person typing something. That's what it always is. And so by sort of not getting the government to do something, or by trying to just ban it, you actually cut yourself off at the knee. As I explained earlier, because more software and hardware integrate AI tools, your phone is full of AI tools. It's constant. If you work professionally, you will be tasked, I say may, but you will be tasked with working with AI systems. And as such, you are not currently afforded residuals or royalties from that work. And that's a huge change, because typically if you're a professional artist, it's often part of your contract that you would see some residual. For example, if you were working for Marvel and you created the next Green Lantern, you would be getting royalties forever. If they continue to use that character, every time they use that character, technically you're getting something back because you're the creator of that character. However, if it was done with AI, then perhaps no longer the case. And that's something no one's talking about. I mean, I've been working in this field now for nearly 3 years, and I don't really see AI as its own thing. I think you have digital art, which is using a computer, and then you have practical art, which is more traditional or physical, okay? So if you look in film, that's how they determine it. You have practical effects, and you have digital effects, okay? So as soon as you start making that distinction, it's a lot easier to deal with, anyway. So, of course, there can be a blending of the two, but essentially, practical art skills enhance digital art skills. So if you're already a talented artist, you're going to take that with you into the generative field. It's going to make you stronger, not weaker, okay? I also believe that as more and more people are going to be picking the digital arts over the practical ones, it's going to mean there's less artists that can paint and draw, which means that actually price goes up. That's how economy works. So you will end up getting paid more, not less, because there's always going to be a call for a traditional oil painting. And I can only see that going up in value if there are less people able to do it. All right. This is just more turkeys voting for Christmas. So as we shift towards true responsible use, the operator of an AI system will bear the responsibility for its outputs. Some people are voicing privacy concerns, and that might be valid depending on how this is solved. But I think that as soon as you take money for something, that's when the lawyers get involved. So we just haven't really seen it mature into services and products yet. And as that becomes more common, it's definitely going to get addressed. Okay? I would just quickly pull up. I did want to include the image, but I felt a bit bad because if I'd included the image, that I would have been one of the bad guys. So a gentleman won an art competition a couple of years ago with a Mid-Journey picture, and he put about, 6 hours or something into it with Photoshop and all the rest of it, and he won it. And then everyone was really annoyed because he won it with AI, and so it caused a big hullabaloo, right? But he wasn't allowed to have copyright on the image, and he has now lost about $1 million in residuals because of all of the media printing his photo without having to pay him for it, which is quite, like, this is why I keep banging on about the whole, you might find yourself with a lack of protection where artists in the past were protected. Okay, so like I said, that's one of these. And we come to the questions section. Anybody? Yep. Yes, but it would be all about training the correct data set. You would have to be very judicious in what information you're training. That's the only way to remove bias. It's a bit like color shades. If I only train red and green, it doesn't know blue. So really the responsibility for the model trainer is to try and get every color in the scope. And obviously that scope where it applies to, was it law, did you say? Yeah, that's going to be quite complex because obviously there's a big amount of information out there. But I think yes, the answer is yes, but it's a challenge for who's training the model and curating that data set. Yeah. Anybody else? Whoa, can't see him, can't see him. Yep.
This might be a little nitpicky, focusing on something you said.
Sure.
When you said that you can, there's ways to tell if a photograph is real.
Yes. Yes.
And, there are aspects and you can just ask them. But I suppose we do see quite a lot of a photo that someone doesn't want revealed that's fake news or that's a fake picture.
Yeah.
And it muddies the waters in whether or not it was real or not.
Yeah.
We generally don't get the answer.
No. It is true, and it really puts the pressure back on authenticating real images. So, for example, if there are ways with cryptography, it's possible to make sure that an image is actually authentic. And I think that's the direction you've got to go, because the only other direction is sort of everybody has to have identification on the internet. And I think it's better to put the onus on the person publishing. Look at me, this is my signature, and that can't be faked. So I think that I'm not saying NFTs, because I think that's a little bit too much, but the idea of using cryptography to sign things that are published. So for example, Downing Street, they could have a cryptographic signature, which would then prove that a video, it could be embedded in the video. And so then when you see a picture or a video and it's not there, you know it's automatically fake. So I think that's really what has to happen.
But is it happening at the moment?
There are systems that have been developed, but they just haven't been implemented properly. Like, I've actually seen, there was a recent one which was able to look for digital artifacts in images, and so it was able to be presented with video or pictures and then immediately tell what's been manipulated. So that stuff gets better all the time too. So the identification of fakes plus the sort of signature component, I think, is what's going to have to happen. Yeah. Anybody else? Yeah.
With a rapidly moving landscape in terms of technology, what do you think the most important skill set would be for students to learn now to prepare them for their future?
Do you know what? I actually think that literacy in creative writing is actually becoming a huge component, because the thing is, I can write software. I've been writing software for a few decades, and all of the stuff I've written in the last 6 months was written either with AI or with the assistance of AI. You still need to have the fundamental sort of coding practices that you would learn in the first year of a course. So how to actually test your code, how to actually run your code, how to fix basic errors. But the reality is that now, I mean, there's some languages I wouldn't even want to mess with, but because the AI understands them and I understand programming concepts, I don't really need to know the language anymore. I'm able to let it give me the closest to it, and then I can look at that and go, oh, change this, change that. So I think in future, as that gets better, because like I said, the way that you ask for the code is like I would speak to a person. It's not if, loop, for, and. It's none of that. It's, please make me a program which I can use to X, Y, and Z. And then knowing how to run that code and test it, and if it's broken, how to fix the things that are broken. So you're still going to have people taking programming courses, of course. You know, the better you are at it, the better you will be with the assistance. But the difference is that if you're literate and able to speak in plain language or descriptive language, you get more out of the AI. Yeah. Does that answer the question? Or yeah. Is anybody else got any more questions? No questions. Everyone wants to go home, right? All right then.
Well, thank you very much for that.
Thanks, guys.